Hi everyone, our topic is directional derivative. The definition of directional derivative. If w is a differentiable function of two variables and let u be a unit vector, the directional derivative of w at p in the direction of u is denoted by du f of xy, where u is in the subscript of d, is equal to partial f by partial x times u1 plus partial f by partial y times u2. The next definition is of gradient of f. Let f be a function of two variables. The gradient of f is a vector function given by partial f by partial x I plus partial f by partial y j. The symbol is called del, is a vector differential operator and is defined by partial by partial x I plus partial by partial y j. Now the directional derivative in gradient form. Du f of xy is equal to gradient of f dot u. This dot is a dot product between vectors. So it's mean gradient of f is a vector quantity, u is a vector quantity. Thus, to find the directional derivative of f in the direction of the unit vector u, we may dot the gradient of f with u. Question number 1. Find the gradient of f at p if f of xy is equal to x squared plus y squared whole square root and p is equal to minus 4, 3. As f of xy is equal to square root x squared plus y squared and we want to find gradient of f which is equal to partial f by partial xi plus partial f by partial yj at p which is equal to minus 4, 3. So we regard y as constant and differentiate equation 1 with respect to x. So partial f by partial x is equal to 2x over square root x squared plus y squared. Now partial f by partial x at p is equal to 2 times minus 4 over square root minus 4 squared plus 3 squared which is equal to minus 8 over square root 25 which is equal to minus 8 over 5. Now we regard x as constant and differentiate equation 1 with respect to y. So partial f by partial y is equal to 2y over x squared plus y squared. Now partial f by partial y at p is equal to 2 times 3 over square root minus 4 square plus 3 square which is equal to 6 over square root 25 which is equal to 6 over 5. So gradient of f at p is equal to partial f by partial x at pi plus partial f by partial y at pj. So partial f by partial x at p is equal to minus 8 over 5 and partial f by partial y at p is equal to 6 over 5. That's why gradient of f at p is equal to minus 8 over 5 I plus 6 over 5 j. Now question number 11. Find the directional derivative of f at the point p in the direction of u. Function is given and the point is given and the vector u is also given. As f of xy is equal to x squared minus 5xy plus 3y squared and we want to find du f of xy which is equal to partial f by partial x times u1 plus partial f by partial y times u2. This means we have to find partial f by partial x, partial f by partial y, u1 and u2. For finding partial f by partial x, we regard y as constant and differentiate equation 1 with respect to x. So partial f by partial x is equal to 2x minus 5y. Now partial f by partial x at p is equal to 2 times 3 minus 5 times minus 1. So 6 plus 5, which is equal to 11. Now we regard x as constant and differentiate equation 1 with respect to y. So partial f by partial y is equal to minus 5x plus 6y. Partial f by partial y at p is equal to minus 5 times 3 plus 6 times minus 1, which is equal to minus 15 minus 6, which is equal to minus 21. As u is equal to square root 2 over 2 times I plus j, so we can write u as square root 2 over 2i plus square root 2 over 2j. So this means that u1 is equal to square root 2 over 2 and u2 is equal to square root 2 over 2. Now du f of xy is equal to partial f by partial x times u1 plus partial f by partial y times u2. So du f of xy at p is equal to 11 times square root 2 over 2, because the value of partial f by partial x is 11 and the value of u1 is square root 2 over 2, plus minus 21 times square root 2 over 2, because partial f by partial y is equal to minus 21 and u2 is equal to square root 2 over 2. So du f of xy at p will become square root 2 times 11 over 2 minus 21 over 2, which is equal to minus 5 square root 2. Thank you for watching our video.